Innovation has always been at the heart of farming, and that is why we are here finding new ways to improve it using data science. Over the year, our team has worked with Beck's hybrids to improve seed quality, which results in better germination, faster emergence, and stronger growth. Our research has helped the team identify factors within Beck's seed germination tests that they can control and potentially improve in order to maximize yield on every single acre in Beck's market. 2023, we split into the plant and harvest date team and the moisture level team to divide and conquer. The plant and harvest date team used data from the percent yes location, plant and harvest date, and final yield to make visuals. When comparing female plant date and final yield, we found that in 2021, the main planting season was from late April to all throughout May, and that the highest yield was in late May. We also found that the main harvesting season for final yield and harvest date was centralized around October and had an upward trend from late September to November. Then, when looking at percent yes, which is the percent of crop that meets the genetic requirements, we found that it was high. This shows that most of the crops do meet the correct genetic requirements. There's also a very small percentage of variance across the different locations in 2021 and 2022. Furthermore, the moisture level team used average harvest moisture level, recommended moisture, and germination values to make visuals. When looking at a visual of cold germ and average moisture absolute values with a regression line, we found that there is not a clear trend between the two. When looking at a warm germ versus actual harvest moisture, we found that if there is less moisture in the seed, it'll have a better germination score. In the spring of 2024, we split into the hybrid placement team and the saturated cold germ and default team. The hybrid placement team wants to observe the performance of top hybrids across various locations to see if there are any common hybrids that yield higher production. Implementing this, we initially organized our datasets into three key columns: grower, which contains 10 locations in which the hybrids are planted, bushels, which shows the number of bushels that field produces, and hybrid, which indicates the name of the hybrid. Afterwards, the top 20 hybrids were identified based on bushel yield, followed by segmenting the results by location and grouping the hybrids to calculate aggregate bushel yields. In the end, this approach allowed us to observe the top performing hybrids within each location, furnishing us with comprehensive datasets poised for future analysis. Meanwhile, the saturated cold germ and default team sought to evaluate the impact of defoliation, which is a herbicide chemical that is used to dry the corn crop in preparation for harvest. On hybrids looking at metrics like cold germ, warm germ, and saturated cold germ. Firstly, the team partitioned the dataset into defoliated and non-defoliated groups, and then employed a simple two-sample t-test on each pair of the two groups. From that, we uncovered, for example, the fact that average saturated cold germination for fields sprayed with defol is lower than that of fields that have not been sprayed with defol. These endeavors lay the groundwork for future investigations into agricultural efficiency and innovation.